When we look at a material, say steel, we can easily tell that it is solid and gray from first glance. But what we can't tell are its mechanical properties. Things like how tough is it, how elastic is it, or how resilient is it. In this video, I will go over some common mechanical properties of materials, with some examples of each. Starting off with elasticity, which is how well a material can go back to its original shape after being deformed. Some highly elastic materials include elastic bands, bowstrings, and trampoline springs. Next, we have plasticity, which is how well a material can be deformed without breaking. Plastic is an example of, well, a plastic material. Saran wrap and clay stay stretched when you stretch it out, and usually don't break if you don't use too much force. A material that is not plastic at all is considered to be brittle, or fragile, as they break easily as soon as they are deformed. Some examples include glass, ceramics, and surprisingly diamonds. Related to plasticity, we have malleability and ductility. Malleability refers to how well a material can be made into sheets, with gold being one of the most malleable materials. Ductility refers to how well a material can be made into wires, with silver being one of the most ductile materials. Both malleable and ductile materials are very plastic by definition. Next, we have hardness, which is how much a material resists being scratched or penetrated. So even though diamonds are brittle, they are very hard materials, with some other examples including concrete and quartz. Next, we have stiffness, which is how much a material resists being deformed. Some examples of stiff materials include glass and ceramics, which breaks as soon as some deformation is created in the material. A material with a low stiffness is considered to be flexible. Next, we have strength, or ultimate strength, which is how much force can be exerted on a material before it breaks. Strength has several different types. Tensile strength is how much tension, or pulling, a material can withstand. Compressive strength is how much compression, or squeezing, a material can withstand. And yielding strength is how much force a material can take before deforming. Note that once deformed, the material can still withstand some force, which means that its ultimate strength may be higher than its yield strength. Some of the strongest materials include titanium and tungsten. Next, we have toughness, which is how much energy can a material absorb before breaking, sort of like a combination of strength and plasticity. Stainless steel and aluminium are very tough materials. Next, we have durability, which is how much a material can withstand wear and tear. A lot of highly durable materials, such as wood, bricks, and concrete, are used to build our homes. And lastly, we have resilience, which is how well a material can store and absorb energy. This is a combination of strength and elasticity, with rubber being a very resilient material used to make slingshots that store elastic energy quite well. And there we have it. Those are some of the most common mechanical properties, or hidden stats, of materials, which are very useful in the fields of engineering. We will want something durable yet hard to build skyscrapers, like concrete, so building a house made of diamonds is expensive and impractical due to their brittleness. I hope that y'all have learned something interesting today. Thank you for watching, and good luck with everything.